exponential functions. And we're going to start off by taking a look at, we have this equation right here, y equals 2 to the x power. This is the parent function. This is going to help you to graph all kinds of different other exponential functions. For example, if I give you 3 times 2 to the x minus 4 power plus 6. Once you can graph this one, what you're going to do is take your table of values, and we've done so many of these transformations. What do you think you would do with your table? So the graph of this compared to the graph of this is shifted how many units? What would you guess?
4 units right.
It's going to go 4 units right, and then 3 vertical stretch by 3, and 6 up, right? On your table, do you remember what you would do once you get your table? What would you do to the x values? What would you do? Add 4, and then take the y value and multiply by 3, and then add 6 to the y. We talked about this, okay? So let's get a base for y equals 2 to the x. So if we use these, and you've got a lot of points here, you may not need them all, but if I put a negative 3 in here for x, I've got 2 to the negative 3 power, and I'm going to zoom in a little bit on this. Zoom in. Okay, so how do you do 2 to the negative 3 power? How do you change it to a positive exponent? What is it? 1 over 2 to the third, or 1/8. 2 to the negative 2 power is the same as 1 over 2 squared, which is equivalent to 1/4. 2 to the negative 1 is the same as 1 over 2 to the first, which is 1/2. What is 2 to the 0 power?
0.
Not 0.
1.
1. Anything to the 0 power is 1. How about 2 to the first? 2, then 4, then 8. Let's graph these points. Negative 3, 1/8. Negative over 3 up an 1/8. Over 2 up a 4th. Negative 1/2. 0, 1. 1, 2. Then 4. And then 3/8. So what you're going to do with these points is you're going to connect them with a curve. It's not a straight line. Now, can you tell me what is the domain? What are the possibilities of x values that we can plug into this function? Is there any number we can't plug in? So the domain is all real numbers. We can put any number into this problem that we want for x. But the range, what is happening? This is getting very large. As x increases, y is increasing. But over here, as x decreases, so does y. But is it ever going to hit, if we kept going smaller for our x values, if we did negative 4, negative 5, negative 6, what's going to happen is you're going to get a smaller and smaller fraction, but it's never going to hit 0. Okay, so our range is going to be y is greater than 0. So now, if I asked you to graph this problem, what I would do, I would take my table of values. I would take this table of value, and I would add 4 to the x values. I'd multiply the y values by 3, and then add 6 to the y. And that's how you would graph it by hand. Let's do the next example. How do you, now this one's going to be exponential growth or decay? Why?
Fraction.
Because you have a fraction. Good. It's between 0 and 1. How do you do 1/2 to the negative 3 power? What is that equivalent to? What do you do when you have a negative exponent? You
Move it to the
flip
bottom.
it, move it on top, and so it's gonna be really 2 to the third, which is, what's 2 to the third? 8. How about 1/2 to the negative 2 power? What's that equivalent to? 2 squared or 4? 1/2 to the negative 1 power is 1/2 is 2, sorry, 2 to the first. Anything to the 0 power is 1. And then if we just do 1, 2, and 3, you get 1/2, 1/4, and 1/8. Plot these points. Over 3, up 8. Negative 2, 4. Negative 1, 2. 0, 1. And then we have to keep going down. That graph, smooth curve, and like we thought, it's going down. As x increases, y decreases. Can you tell me what the domain of this? Is there any number that we can't take 1/2 and raise to a power? Huh? No, there's no number. So all real numbers is your domain. So all of these exponential functions, your domain will be all real numbers. Now what's the range for this? Yeah. How are these two graphs related? How are they related?
Domain and range.
The domain and the range are both the same for this. The domain is all real numbers, and the range was y is greater than 0. Is there anything else that you noticed was the same?
Parent function.
The what? The parent function was different. One was 2 to the x, one was 1/2 to the x. Is there any point that you see that's the same? Yes.
The y-intercept.
The y-intercept. Why is the y-intercept the same? They were both 0, 1. Where do you get the y-intercept? Where does the y-intercept come from? The number that's in front of your base, that's your y-intercept, and in both cases, it was a 1. That's how you get your y-intercept. Where do both curves cross the y-axis? At 0, 1. And where do they cross the x-axis? They don't. They don't cross the x-axis. Now, will they ever? Will they ever cross the x-axis? Yes, they will.
Will there ever be a reflection over the
Yep,
x-axis?
Yep. If you have, just like we did on the other problems, if you have, let's say, if I gave you this problem, that's a reflection over the x-axis. So now your graph, instead of it looking like that, it's going to be like this. That's a reflection. Now, how do you do this problem? You would take your table and you'd multiply the y values by negative 3. So it's not only it's a reflection, but it's also a vertical stretch by 3. Now, what if there was a negative up here? Y equals, let's say, 3 times 2 to the negative x. That's a reflection over the y-axis. So normally this would look like this, but now it's going to be going that way. So this one you would multiply the x values by negative 1 and multiply the y values by positive 3. Do that. Okay? All right, now we just talked about exponential growth was that first example. In exponential growth, what do you notice? What was the first indication that you were going to have growth when you looked at your equation? What told you that you were going to have growth in that? What was the indicator? The what? The base. If the base is greater than 1, it's a growth problem. Invert growth as x increases, so does y. It grows by a fixed rate. And for decay, it's the same formula, a b to the x, but the b value when it's a decay problem is what? Is it greater than 1? Is it less than 1? What is it? B is gonna be less than 1, but it's gonna be between 0 and 1. So that's gonna tell you, and it's, what's happening is X is increasing, Y is decreasing. They do the opposite, okay? Now, we learned last semester how to determine if a table of values was linear, quadratic, cubic. Do you remember how to do that based on the common differences? Remember if you subtracted or added the same number to the y values, it was a common difference, and then you said if the first set of common differences were the same, it was linear. The second set was the same, it's quadratic. If the third was cubic, fourth it's quadratic, quartic. Well, for these, we're gonna go through these and talk about which is which, but with exponential, instead of there being a common difference, there's a common ratio. You're either gonna multiply by the same number or you're gonna divide by the same number for it to be exponential. So let's investigate these, see if we can figure it out. So here's A. To go from 4 to 14, I'm not multiplying by a number, but I'm adding what? 10. From 14 to 29, how much are we adding? 15. So to go from 14 to 29, what you did was add 15. How about 29 to 49? What did you do?
20.
You're adding 20. Now, if these numbers were the same, we would say this is a linear function, but it's not. So we're going to go and see if we have a second set of differences. How do you go from 10 to 15? Add 5. How about this? Add 5. So what are you going to say this is? This is a quadratic. Because we have a common set, second common set of differences. Okay, how about the next one, B? From 10 to 20, we're adding 10, but then we're adding 20, and then we're adding 40. How about, let's look at a product. Can we multiply to get the same? Can we multiply a number to get to the next one? 2? Does it work in all cases? Yep. Well, it looks like they're all being multiplied by 2. So this is an example of exponential. Now, I'm going to show you how to write. How do you write the equation of this? Well, this is the formula. Here's your little recipe. The b value is that base. The a value, you got to go backwards and find out what this is. This is going to be your a value right here. That's your a. So if going forward is multiplying by 2, how do you go backwards? Divide by 2. So what is a? A is 5. To go forward, you multiply. To go backwards, you're going to divide. So what is your equation? Y equals, you're just going to put a 5 in here, times 2 to the x power. Look, let's investigate C. How do you go from 7 to 11, 11 to 15, and from 15 to 19? What are we doing in all these cases? We're adding 4. So what's this?
Linear.
This is linear. For fun, would you know how to write this equation? Just to review. I'll give you the little formula. Y equals mx plus b. You know how to find the slope? It's the difference of the y's over the difference of the x's. So the difference of the y's is 4, the difference of the x is 2. What's 4 over 2? So the slope is 2. And we have to go back, we need the b value. So you're going to go backwards 2 and go backwards 4. What's this? 3. So that's your y-intercept. That's old stuff. How about this last one, D? What's that? How do you go from 20 to 80, 80 to 320, 320 to 1280?
1260.
What are they multiplying by?
4.
Can you give me the equation now? Is this linear? Quadratic? What is it? It's exponential. And can you tell me what the equation would be? Y equals
5 times 4.
5, good. How did you get 5?
Divided by 4.
You gotta, instead of multiplying by 5, you're gonna divide this by 4 to get 5. Good job. Okay, so what we talked about is if a table has a constant second difference, it's quadratic. If the y values have a common first difference, it's linear. And if there's a common ratio, in other words, multiplying from one to another, you get the same number. Multiplying, it's a exponential. These are the three ones we're going to be talking about. With the linear function, you should notice both y and x are first degree. With the quadratic, you notice that y is to the first power and x is to the second. And for an exponential, you're going to see a y, and you're going to see the exponent is your x. That's how you know it's an exponential function. So very quickly, I bet you 7, 8, 9, and 10, you could tell me what they are just looking at the equation. What's 7? Is it linear, quadratic, or exponential?
Quadratic.
It's quadratic. Because it's x squared. How about 8?
Linear.
Linear. Because both x and y are the first power. How about 9?
Exponential.
Exponential. And the last one,
Quadratic.
quadratic. Good job. How did you get quadratic, John?
X times x is
Yeah.
x squared.
So you had to do a little work. All right, now, there are two formulas that apply to this exponential section. One is compounding interest. Now, when you start putting money into a savings account, the bank is going to give you interest. They take your money and they give you a little bit back. And what they do with your money is they use it to loan people money, and then they charge a higher interest rate to them. So, and that's how banks make money. So what they do, so you don't put your money under your mattress, they want you to put your money with them. They're going to give you a little bit, and you got to know whether you're compounding interest monthly, quarterly, annually, biannually, semi-annually, biannually. Here it is. I want you to write this down. The number of times a year that you earn interest is your N value. N is the number of times a year you earn interest. Interest is earned. So this is what you need to know. So if they say annually, N is 1, that's once a year. Annually. If they say semi or bi, semi or biannual, that's 2, twice a year. If they say quarterly, how many quarters are there in a dollar? 4, N is 4. If they say monthly, how many months are there in a year? 12. If they say daily, how many days are there in a year?
365.
And I'm going to give you another one for fun. If they say every other year, it's semi-annual. It's with an E. And that is N is a half a year. Half a time a year. So every 2 years you earn interest.
Is this spelled like that?
Yeah. I think there's 2 N's. Okay, so now we're going to use this formula, and you need to memorize this formula. A is the amount of money that you're gonna earn in time. P is the principal amount that you're gonna put in. R is gonna be the interest rate in the numerator. N is gonna be the number of times you're earning interest. And then you're gonna raise this is your multiplier. You're gonna raise just this to the N, it's an N times T. These two N's are the same. Okay, so there's 4 questions, even though it says A, B, C. There's also a D here, I want you to do daily. So, I'm gonna give you $100 to invest for 10 years, earning 5% interest. I want you to do semi-annual, I want you to do annual, semi-annual, quarterly, and daily, and compare the 4 problems. So now, this is your formula, right? Start with A equals P times 1 plus R over N to the N times T power. The more you write that formula out, you will have it memorized. So putting the numbers down first before we pick up our calculator, we're gonna put $100 into our account. We're gonna multiply that $100 by 1 plus, the interest rate we said is 5%. You always write your interest rate as a decimal, 0.05. Now, if you're compounding interest annually, N is 1. So you have a 1 here, and then a 1 here, and we're doing this for 10 years. So now I'm going to have you grab your Inspire, show you how to type this in. Okay, everyone should be calculate. Okay, you're going to type in 100. And then hit your parenthesis button and let me know if you don't find it. Parentheses all the way to the left. You're gonna do 1 plus. Now, how do you get the fraction bar? The fraction bar is this button right here. In case you don't know that, it's right by the book. Hit that button.
Use the divide.
Huh?
Could you just use the division?
I want you to use the fraction bar. I want you to see this fraction bar right here. And that's it right there, fraction.
How'd you get that?
You go to this button right here. Looks like a bunch of boxes. Hit that, and then it's the very first button, hit the middle. Do you see it pop up?
Yep.
Okay, now you're gonna type in 0.05, and then arrow down. I just, even though it's a 1, I want you to still just get in the habit of doing it. Now, I need to get my cursor over to pass that parenthesis, so just arrow over. Now I want to hit the power button, make sure you power, and then it's 1 times 10. 1 times 10. So do you have that typed in your calculator like this? Then hit enter, and you should get 162.89. So write that down. So now, how will this formula differ for semi-annual? What's going to be different? It's going to be 100 times 1 plus, it's the same interest rate, but now semi-annual means twice a year. So you're going to have a 2 here, and then it's 2 times 10, because 2 is n in 10 years. So do this one, 100, parenthesis, 1 plus, do your fraction bar, 0.05 over twice a year, because it's semi-annually, and then raise it to the 2, n is 2 times 10 years, and hit enter. And tell me if you got $163.86. Anyone not get that? Did you get that, 163? Okay, how are you gonna do quarterly? 100 times 1 plus 0.05 over 4, and then 4 times 10. So please do that one for me. 1 plus fraction .05, and then over 4, arrow, power, and then some of you can do 40, do that in your head. I got $164.36. And what's daily gonna be? What's different? These two n values will be 365. So 100 times 1 plus 0.05 over 365 over 365 times 10. Right sideways. Now you would think that it's going to be a lot different. What'd you get for an answer?
64, 87.
Mm-hmm. Now, if you ever make a mistake, like I was just typing this and I wrote 365 and I realized I'm multiplying, hit delete. You just go back, delete, delete, and then hit your. And did you get, that's your answer. So even though you're compounding interest daily, it's just basically pennies from quarterly, right? $164.87. And make sure you guys, you put your dollar signs. Now there's another formula, but it's not difficult. It's actually easier than this last formula. Sometimes banks will give you interest continuously. Continuously is defined by this equation. A is the amount you're gonna earn, total with the interest and all, equals P times E, it's A, and sorry that's hard to read, P times E is a number, E is approximately equal to 2.718. There, it's an irrational number, it does not stop, it doesn't end, it goes on, it's like pi, it's an irrational number. So now, if you see compounding continuous, you're not gonna use this formula right here, you're gonna use this one first. So if it says, suppose you won a contest at the start of 5th grade, and you're gonna deposit $3,000 in an account, earning interest continuously. You're gonna do 3,000 times E, and now the interest rate is 5%, always convert it to a decimal, and for 4 years, I wanna know how much money are we gonna have at the end of 4 years. So, how do you type this in your calculator? You do 3,000, now the E button is on the left, underneath the arrow, the upside down V. So just hit E, and then raise that, it prompts you to a power, either the what power, and then do 0.05 times 4. And hit enter. Did you get $3,664
Yes.
and 21 cents? Did anyone not? You are responsible for knowing these formulas, and you have to know when to use each one. So, the back side is your homework. I'm going to warn you though, on question 8, they're asking you, and I'm going to just tell you really quick so you don't all look at this and say, what? They're asking, when you double something, this question is giving you $5,000, investing the T value's 25 and the interest rate's 10%. If you double the amount that you're investing, what's this going to be? Instead of 5,000, what's it going to be? 10,000. For B, it says if you double the interest rate, so if you double 10%, what's it going to be? 20%. Good. If you double the investment period, so instead of it being 25 years, it's going to be double 25 years, what do you get?
50.
50 years. And then take these three answers, and it says which of the above gives you the greatest effect. So you're gonna get three different numbers, and you wanna compare your results, okay? And that's your homework. So you have the rest of the time, use the calculators and try to get this done.